Hello everyone, welcome to my lecture. I hope all you are doing very well. In this video, I'm going to introduce the customer classification method by using RFM matrix. Are you ready? Then let's get started. We've learned that customer loyalty is sometimes not enough to identify profitable customers because there are some customers who are loyal but not profitable, and some others who are not loyal but profitable. We have also learned several metrics to measure customer profitability. At the individual customer level, size of wallet and share of wallet are a good tool to identify customers. We can classify customers by those metrics and develop appropriate marketing strategies for each of the customer groups. In this lecture, we are going to discuss customer classification in general and learn another useful technique for customer classification using customers' historical data, which is RFM. Identification of profitable customers is a classification task. It is all about how to correctly classify customers into profitable and not profitable groups. Of course, if we classify at a final level, like the most profitable, so-so, and loss-making groups, we can sharpen our strategies more in details. In general, classification is a task of scoring and sorting. For lots of entities, we first evaluate or score each entity in terms of various factors. We then sort the entities by classification criteria and assign them into several groups we finally want to have. The quality of a classification task depends on the scoring scheme and classification rule given for the purpose of classification. The factors in which the entities are evaluated should be carefully chosen to achieve the goal of the classification. The scoring scheme should be well designed to correctly measure the factors. And the classification rule must result in groups clearly distinguishable from each other. If not, the classification result becomes inaccurate, misleading marketing managers. RFM analysis is a classification tool using three very simple metrics to address the managerial question: who are continually profitable customers? The three metrics are recency, frequency, and monetary value metrics, which are very simply computed from customer transaction history data. For a customer, recency is defined as the time when the customer last placed an order in her transaction history. Frequency is defined as how many times the customer placed an order in the history, and monetary value is the total amount the customer spent on her transactions. From the RFM matrix of the customers in the data, RFM scores are computed for each customer. Then the customers are sorted and classified by the RFM scores. The key of this classification task is to decide the importance order of RFM. There are three scores, so we need to determine the order for sorting. For example, we can sort the customers by recency first, frequency next, and monetary value last, or frequency first, monetary value next, and recency last, or monetary value first, recency next, and frequency last. The order depends on how critical to predict profitability each score is. If it is found that there is a strong, clear tendency that the customers who made the purchase more recently spend more, the recency score is the most critical to predict profitability, and customers should be sorted by recency first. In addition, please note that the scores are sometimes called codes or ranks. In this lecture and the following lab, RFM scores, RFM codes, and RFM ranks all are used frequently. Okay, that's the brief overview of this lecture. Now, I'm going to introduce a conceptual example for your better understanding in details of classification. This example is not an RFM analysis. It is about what you will face in your life, which is the best real-life analogy of RFM analysis. Suppose that you are a manager in charge of hiring a junior member. Your company is so good, so you received tons of applications. Now, you and your colleagues want to pick some applicants to invite for an interview in an efficient way. For simplicity, you have the following information about each applicant: recommendation letters, undergraduate GPA, and related work experience. So, you first evaluated the applicant's documents. For example, there is an applicant, Mr. Timo, and his letters are useless. His undergraduate GPA is poor, and he doesn't have any related work experience. Whereas, there is another applicant, Ms. Leona, and her letters came from reliable people, and her GPA is wonderful, and she has lots of internship experience related to the job. So, you almost finalized the list of interviewees. Ms. Leona is definitely included in the list, but Mr. Timo is not. Now, you need to pick one more guy between Ms. Joy and Mr. Lee Shin. Both applicants have good recommendation letters, but each one has a weak point. Ms. Zoe's experience is relatively weak, and Mr. Lee Shin's GPA is not good enough to prove his background knowledge. The problem is that you don't know which factor between GPA versus experience is more critical. If GPA is more critical, you are going to pick Ms. Joy because her GPA is better than Mr. Lee Shin's. But if experience is more critical, your choice will be Mr. Lee Shin instead of Ms. Joy due to his better experience record. Then, how to know which factor is more critical? You may ask senior managers for their wisdom, or you may rely on your own gut. And there's one more option. You can look back at past recruits. Again, if GPA is more critical, classification by GPA predicts job performance better than experience, all else being equal. Otherwise, experience works better than GPA. And for each of the past recruits, both of the factor scores and actual job performance are available. So, you did a simple simulation. You suppose that you are at the moment when the company hired the recent recruit, classified them by GPA score and by experience score, and investigated which classification predicts their actual job performance better. This table shows the result. Past recruits were sorted and grouped by GPA score first and experience score second, and the average job performance score was computed for each group. For example, Group AAA indicates a group of past recruits who received the grade of A on all factors, and the average job performance score of the recruit in this group is 90. If GPA is more critical, the better GPA group has to outperform the better experience group. So, you compared the average job performance score between Group AAB, the better GPA group, and Group ABA, the better experience group. But, as in the table, the result is reversed. Group ABA outperformed Group AAB. Also, you found another evidence. You investigated the effect of the GPA scores on the job performance scores by comparing the job performance between two groups where the two are different from each other only in the GPA score, like Group AAA versus Group ABA and Group AAB versus Group ABB. But the result says GPA doesn't make any change in the job performance score. Group ABA's job performance score is 88, which is very close to Group AAA's score. And the same result is found in the other pair. Group ABB's job performance score is 54, which is almost the same as Group AAB's score. You also investigated the effect of the experience score in the same manner. You compared the job performance between two groups where they are different from each other only in the experience score, such as Group AAA versus Group AAB and Group ABA versus Group ABB. Then you found that the experience score has a significant effect on the job performance score. Group AAA shows much higher job performance score than Group AAB, and Group ABA shows much higher score than Group ABB. Based on this study, you finally picked Mr. Li Xin instead of Ms. Joy. This example implies that the given scoring scheme and classification rule can be tested or validated with past data. In past data, the actually realized outcomes are also available. So, as you did in the example, you can do a simulation in the following steps. First, suppose that you are at the time the outcomes came out. Second, make your prediction based only on the data that were available at that time. Third, evaluate your prediction by matching the predicted outcomes against the actual outcomes. If your scoring scheme and classification rule are valid, your prediction must be reasonably accurate. And this process is called a holdout validation. Graphically, the holdout validation can be described as follows. The holdout validation is a simulation where we know the correct answers. In the simulation, we know the outcomes of all entities as in this figure. A blue entity indicates its actual outcome is high, whereas a red entity indicates its actual outcome is low. Then we just pretend to know nothing of the actual outcomes and just do the classification. Once we have the result, we can check whether the entities are correctly classified or not with the correct answers. Like this figure, where most entities in the high group are blue, but most in the low group are red. This accurate result proves the scoring scheme and classification rule used in analysis. But like this figure, the inaccurate result disproves the scoring scheme and classification rule. This example is a good analogue of RFM analysis. RFM analysis has been widely used in various contexts. But there is no free lunch. There is no one ultimate rule which is proven for any product categories in any context. All classification rules used in the RFM analysis in practice have been tested by a series of holdout validations. Now, you are ready to dive into the RFM world. Let's go! RFM themselves are a very intuitive concept. It came from simple conjectures. Customers who purchased more recently are more likely to purchase again than the others. Customers who made more purchases in the past are more likely to purchase again than the others. Customers who have spent more in total in the past are more likely to purchase again than the others. For example, here is a screenshot of RFM. There are two customers, John and David, and these tables show their transaction histories. John made 5 transactions or purchases in the data, and the last purchase date is July 31st, 2018. And his net spending is $650. David made only 3 transactions, but his last purchase date is more recent, September 22nd, 2018. Also, his net spending is $1,080, which is more than John's net spending. So, John's recency score is low, frequency score is high, and monetary score is low relative to David's scores. In practice, RFM metrics have been widely used to identify who to target. That is, RFM metrics have been used to address managerial questions such as, when you introduce a new offer, who are most likely to respond to the new offer? When you send out discount coupons, who are most likely to spend much with the coupons? You might not believe me. How do the super simple metrics predict profitability well? So, here is an empirical example. There was a company with 400,000 people of its customer base. The company randomly selected 10% of the customers and sent out a $150 discount coupon to them. Out of the sample customers, 808 customers placed an order with the coupon, so the overall response rate is 2.02%. To investigate the efficacy of RFM metrics, a marketing manager of the company divided the sample customers into 5 equally sized groups by recency, frequency, and monetary value. Here is a result of grouping by recency. Again, those 5 groups are equally sized, meaning that the top 20% customers in recency make the group 1, the next 20% make group 2, and so forth. This figure shows the response rate of each group. Group 1, which is made of the customers who made the purchase most recently, shows 4.5% of response rate, which is much higher than the overall average 2.02%. And Group 2's response rate is also clearly higher than the overall average. But the other groups' rates are clearly lower than the overall average. This implies if the company had selected targets by recency, the response rate would be much better. Grouping by frequency shows the same result, although the effect size is weak. There are 5 groups, and those groups are made in the same manner. The customers who made purchases the most times make group 1, and those who made purchases the least times make group 5. As you can see, groups 1, 2, and 3's response rates are higher than the overall average, but the other groups' rates are lower than the average. This implies if the target had been selected by frequency, the response rate would be better. Grouping by monetary value shows the same result, even with much weaker effect size. Customers who spend the most show the response rate higher than the average, but those who spent the least show the rate lower than the average. This implies monetary value-based selection of targets would improve the response rate. Now, I'm going to explain the details of RFM analysis. RFM analysis is basically a simple procedure of the following 2 steps. First, score customers by recency, frequency, and monetary value metrics. Second, sort the customers by the RFM scores and select the customers at the top of the list as the targets of marketing activities. The optimal number of targets depends on the marketing budget and the cost to be incurred. With a large budget and a low cost, we can target more customers. Then, let's go into the details of each step. There are various scoring schemes, but mostly used scheme is this simple one. First, sort customers by each metric. For example, to score customers' recency, we need to first sort the customers by their most recent transaction date, as in this table. David is the customer who made his last purchase most recently, so he is at the top of the table. Next, divide the customers into equally sized groups and assign a code to each group. For example, let's score customers' recency with 3 groups. Then, the top 33% customers in the list are assigned into group 1. The next 33% customers are assigned into group 2, and the bottom 33% customers make group 3. The group number to which each customer is assigned, 1, 2, or 3, is the recency score of the customer. The next step of RFM analysis is to sort the customers by the RFM scores. The sorting result entirely depends on the sorting order. For example, the left table shows the result of sorting by recency score first, frequency score next, and monetary value score last. The best customer in all scores is David, followed by Anna, Kate, Elsa, and Chris. You can find that Chris is the last, even though his frequency score and monetary value score are high due to his low recency score. But when the customers are sorted by monetary value score first, frequency score next, and recency score last, as in the right table, Chris is next to David, followed by Elsa, Anna, and Kate. So, if the company picks targets in the left table, David and Anna are highly likely to be selected, and Chris may not be chosen. But in the right table, instead of Anna, Chris is highly likely to be selected. Then, how to determine the sorting order or the importance order of RFM? Please recall the hiring example. We can use the holdout validation strategy to figure out the best one. The next example illustrates how to do a holdout validation in RFM analysis with CD-Now data. CD-Now was an online CD retailer founded in 1994. It was famous for its preference-based recommendation system. The company was merged to Bertelsmann in 2000 and to Amazon in 2001. The data are individual level transaction history data from January 1st, 1997 to June 30th, 1998. Let's take a look at the data. Each record contains the information of a transaction, including who made the transaction, when the transaction was made, and how much was spent in the transaction. The detailed design of the holdout validation is as follows. First, we suppose that it is a day in the middle of the entire time period. Next, using only the data before that day, we are going to make predictions of who would purchase more and spend more after that day. Last, we are going to match the predictions against the actual data after that day in order to validate the efficacy of the RFM scores and the sorting order used in the prediction. Okay, let's go into the details of each step. In the first step, we need to pick a day in the middle of the time period. The midpoint is October 1st, 1997, so we split the data into two periods. One is the period before the midpoint, and the other is the period after the midpoint. For convenience, the first period is called calibration period because we are going to make predictions using the data in this period. The second period is called validation period because the data in this period will be used for validation. In the next step, we make our predictions following the grammar of RFM analysis. To do so, we need to compute RFM scores. As I mentioned, we are using the data in the calibration period only for prediction. So, the recency metric is given by the last purchase date in the calibration period. The frequency metric is given by a pivot table of the number of transactions by customer. Only the transactions in the calibration period should be counted. We summarize the number of transactions by period as well as customer. The monetary value metric is also given by a pivot table. The table summarizes the net amount of dollar spent by customer and period. From the RFM matrix, we now compute RFM scores. For simplicity, we consider only two groups for each score. For example, the 50% of customers in the recency matrix are assigned to recency code 1, and the other 50% are assigned to recency code 2. Now, we classify customers by the RFM codes. Here, the importance order is assumed to be RFM, that is, the customers are sorted by recency code first, frequency code next, and monetary value code last. This rank column contains each customer's overall rank, which indicates in which group the customer is classified. Rank 1 means the best scores, that is, customers in this rank have recency code 1, frequency code 1, and monetary value code 1. Here, you can find that customers with recency code 2, frequency code 1, and monetary value code 1 are classified into rank 3. So, the customers in a high rank are predicted to purchase more and spend more than those in a low rank. The third step is the validation. Let's look into the recency score first. If a recency score works, the high recency score, which is recency code 1, indicates more purchases and more net spending during the validation period. The figures shows that during the validation period, the average purchase frequency of recency code 1 is much higher than that of recency code 2. And the average net spending of recency code 1 is also much higher than that of recency code 2. So, this result clearly proves the efficacy of the recency score. As for frequency score, you can find a similar result that strongly supports the efficacy of the frequency score. During the validation period, the average number of purchases of frequency code 1 is much higher than that of frequency code 2, and the average net spending of frequency code 1 is also much higher than that of frequency code 2 customers. The result also clearly supports the efficacy of the monetary value score. In fact, the monetary value score is perfectly correlated to the frequency score, meaning that customers who bought CDs more times always spent more in the validation period. This makes sense because this data set is a retail sales history, so there are no customers who bought the bulk of CDs in one transaction. Finally, let's look into how correctly we predict customer transaction frequency and net spending in the validation period. That's also about the validation of the efficacy of the sorting order we used. The sorting order we used is RFM, that is, the customers were sorted by the recency code first, the frequency code next, and the monetary value code last. If this sorting order is valid, customers in a high rank should purchase more and spend more in the validation period. However, the data doesn't support the prediction. The customers in rank 3 purchased more and spent more than those in rank 2 in the validation period. Rank 3 means high frequency and monetary value scores, but low recency score, and rank 2 indicates low frequency and monetary value scores, but high recency score. This implies frequency and monetary value are more critical than recency to predict customers' future purchase frequency and net spending. Thus, the valid order is FMR instead of RFM for this dataset. Alright, that's all I have in this lecture, and let me wrap up with a short summary. RFM are well-proven metrics to classify customers and identify who to target based on transaction history data. The holdout validation strategy is generally used to prove the effectiveness of classification using RFM metrics and determine the importance order of RFM for classification. Of course, RFM do not always work. The RFM analysis has several limitations. First, like CD-Now data, recency, frequency, and monetary value are sometimes strongly correlated to each other. This is frequently observed, especially for frequency and monetary value in various data. By definition, purchasing more times means purchasing more units, and the net spending increases as the purchase volume increases. Thus, the frequency is correlated to the monetary value in various contexts. Second, RFM sometimes fail to predict. An example is frequency paradox. Consider a customer who used to very frequently place an order but now is inactive. So this customer's recency is low. This customer may not respond to any offers. Then, what if there are many inactive customers like this customer? It can be observed that the higher the frequency, the lower the response rate in a low recency group. That is, without consideration of inactiveness, standard RFM method classifies such customer as to be targeted due to her high purchase frequency in the past. Third, RFM sometimes are not enough to describe all of consumption behaviors such as clumpiness of purchases. A customer's purchases are clumpy if it is occasionally observed that only a mass of shopping occurrences were made in a short period of time in a transaction history. An example is digital content consumption. There are so many people who admit to binge watching their favorite TV show on Netflix or Hulu or playing a new Xbox games over the weekend. In such a context, clumpiness or binge-like behavior is another factor characterizing the value of a customer, and thus clumpiness needs to be considered as well as RFM to identify profitable customers.